There we go. Good afternoon, everyone. Thank you for joining us for our next edition of Future of Engineering Roundtables. We're very excited about today's session and the topic of AI, which I know is top on everyone's mind. I did want to start out, though, and recognize our donors who make this research and these roundtables possible. Thank you to all of you who are contributing. For those of you who have been watching some of our past series, you know this list is continuing to grow, and we look forward to adding your name and or logo to the list. So please let us know if you're interested in joining us in that effort. But for today's topic, let's go ahead and get started. We have a lot to cover. I'm excited to welcome Nicola Mangan, who is serves as the Vice President for Autodesk's AEC strategy. We're also very fortunate that Nicola serves on the ACEC Research Institute's Board of Directors and shares his vast knowledge and experience with us through that venue as well. We also have Kevin McMahon, who's a senior research consultant with the Institute, who is going to moderate the session. And I will be watching the chat and the Q&A. So if you have some questions throughout, please throw those in, as Carrie mentioned, and we will try to get to as many as possible. But without further delay, I'd like to go ahead and turn this over to Nicola to get started, because I know he has a lot of great information to share with us today. And so, Carrie, if you could give him control, we'll get started.
All right. Good morning, good afternoon, good evening, everyone. I guess you can see my screen. Okay. So I'm Nicolas Mangan, and I lead the strategy for the AEC markets at Autodesk. I've been at Autodesk for about 20 years, and I'm based on the East Coast in Boston, Massachusetts. So today, in this discussion, I would like to focus on two different topics, starting with the digital twin topic, and then we'll have a break with some questions. And then I'll talk about the role of artificial intelligence that we see coming strong in our industry. So let's get started. So in the AEC industry, so architecture, engineering, and construction industry, we already experienced three digital transformations. The first one was about 40 years ago with the introduction of electronic drafting and CAD. The second one was about 20 years ago with the introduction of 3D parametric modeling and BIM, or BIM 1.0. And about 10 years ago, the introduction of the cloud and working with collaborative workflows where we can share information. And actually, during the pandemic, just like we are all on Zoom today, collaborating in the cloud has accelerated. And today, it's the main way of working between architects, engineers, and contractors. So we already experienced a lot of transformations. And today, BIM is the backbone of the digital transformation. BIM is a process that many of you, millions of people in the world are using to really, design, build, and operate facilities. And at the end of the design and construction process, we get a digital twin. So a digital twin is an output of the BIM process. So I'll talk about that. But before we do that, I want to talk a little bit about the key trends that are actually shaping our industry right now, and also influence the need of using a digital twin, but also all of this data that's happening, will be foundational for artificial intelligence. But right now, there are three big buckets of trends happening in the industry. So the first one is about the demand. And what we are hearing is there's more work than ever before. And it's driven by, three things. So demographic shifts, the population is growing, moving in and out of cities, stimulus packages, especially in the US, and also sustainability requirements. Last year in the US, we had more renovation projects than new projects. And it's the first time in the history of this country. And finally, resiliency. We need to protect, repair, existing assets because of all of the natural disasters. So a lot of work, more work than we can do. The second one, it's the way we work has changed dramatically. So first, we don't have enough people to do all of that work. We work remotely. There are challenges in the supply chain. And then, to address some of the challenges around, lack of productivity or not enough productivity, we see an acceleration of industrialization of construction. And finally, the last one, and that's where we'll spend more time, it's the digitalization or the digital transformation of our industry is accelerating. And we see an explosion of data, an explosion of tools. So, today we'll talk about it, but it's everywhere, right? So there are a lot of different things, and it's complicated to deal with all of this technology. The second one is owners are becoming more savvy around technology, and more they are asking for digital twins. And then finally, so a company like Autodesk, we've been doing AI for 6-7 years, and it's embedded in a lot of our tools. But right now, with the rise of ChatGPT, everybody is talking about it, and everybody wants to know what's going on and where we are heading as an industry using what we call generative AI here. So as I mentioned, there's a digital acceleration right now, lots of different things happening, and I will just touch base on digital twins and artificial intelligence today. But when you think about a digital twin, so we need to ask ourselves, why owners want a digital twin? Because today the owners want to get really three things. So they want to get better insights during the design and construction process. They feel they don't have the visibility in terms of what's happening in the process. So they believe that a digital twin during capital project will help them. They want to optimize their assets in the short term. So meaning in the life cycle of operations, when the cost of ownership for the entire asset is about 70%. So they want to optimize, performance. And then finally, they want to reuse the knowledge of, of the design, construction and operation process for future projects, right? So they want to capitalize on all of this knowledge, for the next school, the next hospital, the next bridge, the next road, the next tunnel, right? So they want to capture information during the operations and then reuse it later. But for the purpose of digital twin, we are going to discuss more what owners want to do with a digital twin. The first thing they want, of course, it's a digital handover. And just like we as engineers, we design, we also build a physical asset. What we need to do is also design and build a digital asset. And we don't think that way, right? But our role is going to evolve not only in terms of designing a physical asset, but also a digital asset. But the challenge today is owners want a digital asset, but what they get most of the time is a paper, right? So that's what they get. In some rare cases, they would get different models, and they get these models from contractors. And these models are not really a digital twins. These models are really 3D models that were built for a specific purpose. So sometimes it's for clash detection or quantity takeoff or scheduling, or if it comes from an engineering firm, sometimes for generating drawings or fabrication drawings or structural analysis or whatnot. But the models that they receive is not a digital twin. The information is not organized the way they need it, right? So it creates a challenge for these owners. So what I think is important as we enter a world where digital twins will be more required by owners, it's really describe what should be inside a digital twin. And we started to see, more definitions about digital twin. So starting from the bottom, a lot of what we think most of the time as, architects, engineers, and contractors, it's a digital twin is a 3D model of all the construction data, all the design data, just a physical representation. But actually, there's a lot more that needs to be part of a digital twin for an owner. One of the challenges is owners, don't articulate very well what should be in the digital twin. But when they require a digital twin, they should really ask and be specific about their goals in terms of asking for a digital twin. They need to explain if they want to do, energy management, or if they want to do maintenance or space planning or whatever. But they need to be specific. But you can see here on the left, there's a lot more data like GIS data, but also access control, IoT, IWMS, CAFM, CMMS, type of data to manage the facilities. And the facility, by the way, could be a building. Here I'm using a building, but it could be any other kinds of assets. So today, a lot of what we think about, as I mentioned, is more the construction data. So to help owners, some experts, so there is this company called Verdantix, based in the UK, started to define a little bit more what a digital twin is. And we hope that by defining it, it's going to facilitate the relationship between owners and then architects, engineers, and contractors. So the first level, the simplest model of digital twin is really called a descriptive twin. So it's really the physical representation of an asset. So here it's a building with all of the necessary information about each of the components, the systems, but also the maintenance information. So, and sometimes, it's not all the data of a project. So maybe the reinforcement is not required. Maybe there are things that are not required. Maybe just the description, but not the physical representation for the owners. So that's I would say the first level. And it could apply for buildings, but also for infrastructure projects, just like this train station. This one is in Paris, where I'm from originally. And you can see in this case, that digital twin was created by a large engineering company called Aegis, that maybe some of you might know. So it's an example of also using an infrastructure. And because we love Paris, this is also a project at the city level of a digital twin. So the city of Paris is renovating the area of this tower. I think everybody knows about this tower. And for this, we work with WSP to really create a complete digital twin of this neighborhood where everything was modeled, every single tree, utilities and roads and everything. And in this case, the owner, which is the city of Paris, wanted to have a digital twin really to give it to, different architecture and engineering firms so they can submit proposals for the renovation of this space. So everybody would have the exact same data. They don't need to go on site and measure or get any information about the context. So that was a way the city of Paris used a descriptive model for digital twin. The next level of digital twin, which is critical for optimization or performance optimization, it's really to connect some of the live data. And when I say live data, it's information about, sensors. It could be a deflection on a bridge. It could be humidity, temperature, whatever. But basically what we want a dashboard to understand what's going on the asset in real time with any kinds of sensors. So it's about normalizing the representation of time history data. It's about representing this information on a 3D model, so it's easier to understand the trends. Here's another example here. where we can see different heat maps in real time of the, I think in this case, it's a temperature, but we can also select specific room and understand, dynamically, humidity, etc. So that's the next level. As you know, Notre Dame, burned almost 5 years ago, 4.5 years ago. So we also, for future projects, we also created a digital twin. And then on this digital twin in real time, you can measure carbon, you can measure presence. So, remotely you can understand, the different things happening in this building. Okay, the next level of digital twin is what we call a predictive twin. So in this case, it's about providing, advanced analytics, providing insights, providing warnings about something that's happening in the facility. Here's an example of analytics. So in real time, using computer vision, you can actually track what people are doing. And you can also analyze, for instance, if they go in a specific space, are they going in the right direction or not? So I'll show you this visualization, for instance, where the digital twin shows us during the day where people are circulating in this facility. And it's also based on temperature when we open or close windows. So it's advanced analytics to really track what's happening. So that's the level of insights that you can get from a facility. If it's a bridge, you can look at, traffic, pollution, all kinds of different factors at the same time. The next level, almost the last one, before we start questions, it's what we call the comprehensive twin. And really, in this case, what owners want to do with a twin, it's a real-time simulation. So they want to do what-if scenario. They want to simulate different things happening in the built environment, in the real environment. So one example here that we researched with owners during COVID was really the spread of the virus on high-touch surfaces, but also airborne. And then we could build this model in a digital twin to understand how the virus, would be transmitted from one person to another one. And then that was used by this owner to reorganize, the flows in the building. So it's a good example of using, simulations for understanding what's happening. This last example here, it's Airbus. Here, it's a factory in Germany where they make wings. And as you know, wings are, pretty big. And wings are, I didn't know about it, even though I'm from Toulouse, where they actually assemble some Airbuses. But, it's still very manual, to make these wings. So in this case, we worked with Airbus to really identify, the best path for workers to go and get their tools. And we wanted to minimize, in this case, the distance that they need to walk, to get specific tools. And you can see here, a simulation of a digital twin of the factory, where, we could optimize, the best path forward. So that was an example of doing these real-time simulations and prescriptive analytics, where in this case, the digital twin could recommend, a different way of placing the wings. And then finally, the last level of maturity for a digital twin will be around autonomous twin, where in this case, just like self-driving cars that we have today more and more, the assets, will be also self-driving, if you will, and autonomous and make decisions on behalf of users. Of course, it will be powered by a lot of artificial intelligence, and we'll talk about it in the next section. So just to close on the topic of digital twin, today, if you look at commercial products and where things are, scaling, we are really in the descriptive twin. So that's, most of the digital twins, and then some informative twins, but it's very early. But again, the digital twins are still pretty rare because the owners do not know necessarily how to articulate their needs. We see more with more tech companies, like the Microsoft and Google and Facebook of the world that are very aware of this because of their background, and they are in a better position to articulate what they want. So in other places, we see in Europe, in Northern Europe in particular, we see that the engineering and construction firms, spend time educating the owners about what a digital twin could do for them and how it could improve their businesses, so they optimize their operations. So I'm going to pause.
Nicholas, thank you very much. That was very, very informative, and I think gave us all a sense of the different levels of digital twins. One comment before we get to the first question is, as you mentioned, tech companies are more aware of the possibilities of digital twins, but it sounds like they may also be better skilled at this point at delivering digital twins to our clients. So the industry needs to kind of catch up to be in a better position to advance this needed tool. With that backdrop in mind, how can a firm, whether they're smaller or mid-sized, or even larger, get started creating digital twins? Where do you develop the talent to do this?
Yeah, so we are still in the early days of this technology, right? Just to give you an idea, today about I would say 60% of engineering firms create 3D models. So still only not the entire industry uses 3D models. So I think that number one, the use of 3D modeling becomes more important, and that's where companies need to start. But before we get there, I think a conversation with the client about what they want to do with a digital twin is important. Because if you look 10, 15 years ago, a lot of owners were asking for 3D models or BIM deliverables. In their mind, it was really to get the projects on time, on schedule. But it was not really to use the assets. So now the conversation is evolving, and when owners require a BIM deliverable or a digital twin, I think it's critical to understand what they want to do with it, because you will put some level of information in it based on their needs. Sometimes it's just for measuring things. Sometimes it's to track performance. Sometimes it's for managing the maintenance, etc. So number one, I think asking the client what they want to do with it, and then number two, I think it's critical to say who's going to create what, because what will the contractor provide, what will the engineering firm provide, or architecture, right? So I think this discussion needs to happen, because right now it's not happening most of the time, and then what gets delivered is not what's expected, and then the owners don't leverage this rich information.
Yeah.
To your point, go ahead, Kevin. I was just going to say to that point, Nicola, one of the questions that came through, as far as who is going to be responsible for managing and creating these digital twins, and I think you started to touch on that a little bit. I don't know if there's anything else there.
Actually yes. Actually yes, and if you go back in history, in the early days of BIM, it was primarily the architects and engineers, creating these models, and you saw, folks in the audience, you saw an opportunity to provide more services. Right now, right now it's more the construction companies, that provide these services. But before it was engineering companies. But what we see is that construction companies are not delivering the services. They don't have time. to provide them. So I think there's an opportunity for engineering companies to come back, and engineering companies are very strong in terms of modeling, and they have an opportunity to provide the digital twin, but more importantly, to provide recurring services, not for a given project, but really recurring revenue in terms of maintaining the digital twin, because owners make a lot of changes. They change components in the building, they rearrange spaces, they add some partitions or whatnot. And if we want to be effective in using a digital twin, we need to maintain it, and owners, operators don't have the skills to do that. So I really think that somebody needs to take this as a big business opportunity to manage this digital asset. There are companies that manage the physical asset, right? They go and change things, fix things, optimize, but we need to do the same thing digitally. And I think engineers are the best position to do it.
Yeah, thanks, Nicholas. Sounds like there really is an opportunity for engineering firms to take the lead with data from so many sources. Last question on this topic. It's very fascinating. The data that's available, as in digital format, is it more important on certain project types such as wastewater treatment plants and manufacturing facilities, or will there be equal uses on what we would call more horizontal projects with less operating characteristics, such as highways and transit systems?
Yeah, so I think regardless of the asset, we'll need a lot of data in this digital twin. Maybe there will be when there are consumers or occupants, commercial spaces or residential, there might be more data. That's important. But what's fascinating, and actually I'll talk about it in a minute, but right now there's a lot more data than we used to have. There's a lot of public data. Us, as a society, we are becoming a lot more digital. For instance, we can use AI can process social media information, right? So we can understand by using AI to understand the sentiment of people, for a neighborhood, for a project, for the project that was built last year. And all of this information is really valuable for the owner operators in terms of how they manage the facility, what they do to impact or not impact the neighbors. So, it's just an example, but there's, pollution data, there's, a ton of different data, demographics data. All of this is now available and should influence, what's happening in this facility. So I would say data, the list of data that I provided is applicable, for industrial, water, wastewater, treatment plant, water distribution network, all kinds of assets. Yes.
It's a great revenue opportunity for our industry going forward. Should be really exciting. Hey, I'm going to ask you.
Just before we leave this, I know you want to jump to the other topic, but I think Nicholas touched on this a little bit already, right? That you guys are using it both in horizontal and vertical spaces. Mm-hmm. But who's leading, would you say, Nicholas? Is it coming primarily from governments or from private entities on these digital twin requirements? Who's taking the lead on that? Or is it equal?
I mean, right now, globally, what we see, it's more private, private owners that's required. I mean, I gave you an example of a public, the city of Paris, for instance, or, a train station, which is also, a public, public owner. So we see both, but the growth is coming more from a private owners right now.
Okay, thanks. Sorry, Kevin.
That's all right. There's really an opportunity to take the lead on the public side, in particular. Nicholas, thanks, and why don't you get right into your overview of AI, which everyone is really interested in hearing.
Yes. Okay. So I'm sure everybody heard about ChatGPT. Everybody, it's everywhere. Actually, recently, most of what I've been doing is discuss this topic. And I think I presented to the ACC Research Institute board a couple of months ago, and I said, hey, how about you share with some of our members? So here we are. Okay, so, as I mentioned, the world is changing rapidly. AI will actually be in every part of our lives. We track technology, quite a bit. And if you guys remember, the micro processing power, back in the days, there was the Moore law, if you remember, which said that every year, we double the power of the microprocessors. Remember that? Twice more next year. Here, AI, it's about 100 times, right? So it's crazy. The capabilities, the power, it's just going, it's a hockey stick of capabilities. And today, we'll be impacted in everything we do, right? So that's something we need to learn. And so we've been doing things, in some of our tools, more in the background, to automate things, to give you some insights, but we were not really yet, looking at, co-creation AI, where the human and then the AI, work together to create content very similar to ChatGPT. And that's what I want to, discuss a little bit in this section. But to power AI, first, we need a lot of data. So, and that's what we call the real world data. And today, as I mentioned a minute ago, data is widely available. There's data about the site, and us civil engineers have been using geotech data, water data, terrain data. So it's a lot. I think there's also existing conditions. Existing conditions, it's all of the assets that were created, but here, in terms of existing conditions, it's also the data that we capture from a digital twin. So we know, for instance, that we have data about past projects. We know what happened, during the design, during the construction. We know the performance of the operation. So more and more, there's data. Supply chain. If we want to use industrialized processes, we need to know that we have prefabrication plants, in this area. We need to know the labor conditions. Do we even have labor, to do the work, in a specific area? Societal, it's, demographics and social and political. So all of this data is now available and will influence AI, to co-create projects for you. And finally, as I mentioned, also social media. So number one, there's a lot of data. And remember 2-3 years ago, there was like a buzzword, we talked about big data, right? That's big data. That's what we mean. And only AI can process vast amount of data, trends, libraries, all of that. And now you are going to start seeing a lot more. So, just to connect with what I said before, one of the things around data, it's reusing the knowledge, right? So owners want to reuse the knowledge they captured for their projects and then use it for the planning of the next project. So if they design a bridge, a plant, whatever, they want to use all of the data that they learned, through the digital twin and then reuse it later. That's going to feed the AI. Okay, so AI needs to be powered by better connected data. And I think that's fundamental. And if you think about the future of BIM, it needs to be powered by better data. And first, what we need, there is this concept of a digital thread where data needs to flow from one place to another one. And today, I wish it's happening, but it's not happening. People exchange files, you import, you export, you lose data, you recreate the information, and that's just going from planning to design to construction, and if you're lucky, to operations, right? But the value chain of data, is very fragmented, very manual. And with an explosion of tools, people spend most of their time, managing data and moving data around. And in this case, I'm not even talking about bringing data back for learning, right? So I think that's the second part. So to really empower AI, we need to have this digital thread where the data can flow. And that's fundamental. That's a prerequisite for data. And the way you do it is by changing the way software companies like Autodesk, but many others like Bentley and others need to organize the data. And for us, at the center of it, there is this idea of granular data. And today there are many vertical tools, many tools, point solutions, where files are really associated with with the tool. So moving forward, what you will see from a lot of different companies, technology companies, we are going to decouple the data from the applications. And when we do that, we create a different kind of data repository, if you will, where data is very granular. So when I say granular, it's every piece of data will be at the, of the same currency, whether it's a column, a beam, a line, a circle, a window, whatever, whether you use a horizontal tool or a vertical tool, all the data needs to be the same currency. So if we get to that point, then the data will be able to flow a lot more seamlessly. You don't need to import, export. All of the applications will just access this granular data. But the beauty of it, if it's of the same currency, it means AI technology will be able to identify patterns in the data. And that's what we want. We want the AI to see trends, to cross-reference different kinds of data, the real-world data that I talked about, but also the data about your project. And when they come together, that's where the magic happens, and the AI can really help. And I think this granular data will enable AI to give you a lot of insights, but also to help you co-create. So that's one thing. So first, we need granular data, better data, connected data. The second thing we need to think about, it's a different process. And today, what you see, it's our process. It's fragmented, lots of different tasks. There's always somebody checking the work of the previous person. I give you an example. Engineers check what architects do, for instance, and then architects change the design. So there's some iteration. Pre-con, we do clash detection if it's not done, in the design phase, etc. Right? So there's always somebody, because whatever gets through the value chain, is not perfect. And at the end, we measure the outcomes, such as the cost, time of construction, carbon emission, or whatever. But that's at the end. Imagine a world, very differently, where we define the outcomes in the beginning. And we say, hey, AI, I want a building that's going to cost 200 million. I want it to be delivered in 2026 in February. I want it to be prefabricated. I want it to be net zero or whatever. And then the AI, based on real world context, previous projects, and all kinds of rules, will only suggest options that meet this criteria. That means the outcomes that you want. And that's what we call an outcome-based approach, where here you start with the criteria, whatever they are, and then you get an outcome. And instead of getting the first or the second or the third option, you get the best option, right? So that's long-term vision, right? So, it's going to take a while, it's going to take a decade, before we get to something final. But that's the idea, right? Where there's co-creation, you define your goals, and then the AI will create something for you. So I can show you a couple of examples here that we've done. So simple project. It's actually in the Bay Area, I think on the East Bay near Oakland. So it's a development. And in this case, we asked the AI based on a set of outcomes that you can see here to generate all kinds of options. And then the AI will iterate and find, some solution. It's never going to be perfect. So as a designer, you pick what criteria are the most important. If you say, I want a building that costs $1, with 50 units, it's not going to happen, right? So you need to prioritize your outcomes. So that's an example of AI iterating here. But let's say we make it a little bit more complex. We want to use modular construction, and we built a library of different modules, like a kitchen, like a one bedroom, etc. And in this case, for a given solution that the AI found, we can say, hey, find, the best combination of these modules. So, we meet the cost, we meet the time, we meet, the local requirements, etc. So in this case, the AI for, a set of buildings for one solution iterates and then find the best solution. But we can make it even more complex. In this case, we can ask the AI to iterate not only on the shape of the buildings, but also on the components. And here you get to, hundreds of thousands or millions of different solutions. And the AI will tell you which one is best. That's an example of what we call generative AI. Is it perfect? No, but it's a very first good draft. So I'm sure by now you notice that English is not my first language, right? So when I need to do, write a letter or something, I don't like it because English is not my first language. So I start with a ChatGPT, and then I say, I want a letter like this, for an application for my daughter, for an apartment or whatnot. And then ChatGPT would create a very, very good first draft. And I change it, I tweak it, and then I can keep going and do my work, right? Here it's the same. The AI will give you the best option, not the first option, and then you can keep going. Here's another example of where AI will be useful. So in this case, it's not generative AI, it's what we call informative AI. It's a hospital in Norway, also, for prefabrication. And here the AI can analyze a project, this hospital, and say, hey, you have 22 different types of bedrooms in this hospital. If you want to prefabricate, maybe you need less. So in this case, again, the AI can, suggest. So it's not co-creation, it informs, hey, if you stretch a wall or if you change the room, then suddenly, instead of, 20 types of rooms, you can get 7 types of rooms, right? So it's an example where the AI informs you, gives you insights, and then suggests something, but it's not the creation. Another example here, still on the same topic. So it's a generative AI, where in this case, the AI can pick the right components to create a module, right? So that's a combination of informative and generative AI. The last example I want to show you, and if we have engineers, I think it's mind-blowing for me. So it's what we call predictive AI. And basically what it does, it's really AI doing real-time analysis. So today, if you want to do a structural analysis, non-linear structural analysis or energy analysis or CFD analysis, fluid dynamics, it may take 10, 15, 20 an hour, right? It takes a long time. That's why you don't do calculations all the time. Imagine that there are AI models that can do calculations in a tenth of a second, 0.1 second to do these calculations. Here it's an example of CFD analysis, so computational fluid dynamics, where we can do almost real-time analysis, a tenth of a second, with a predictive AI model. So we don't solve, for the data sets, but we use this predictive AI, and the accuracy is between 90 to 98% accuracy. right? So that's fantastic. So it's another way. So just to close, we have 4 different types of AI. I didn't show too much of co-creation, but generative, co-creation, informative, and predictive. There will be many other applications of AI in the future. That's my last slide that I wanted to share with you. So today we saw these 3 transformations, but we are just at the beginning of a 4th transformation for our industry. And just like we had CAD, we had parametric modeling, leveraging the cloud, we are entering this world. Maybe we call it the future of BIM, or however. Right now, we call it the outcome-based approach as opposed to model-based approach, where the AI will start creating content for you and be part of your processes. Still very early stages, but we are entering this world. And I'm going to pause now.
All right. Thanks, Nikolai. We've got a bunch of great questions in the chat box, and I'm going to ask Daphne to sort out a couple of them. But first, I want to ask you this general question, which I think has got all of our firm leaders thinking. How does a firm develop a grounding in AI so it just doesn't get out of control with every engineer in the firm doing whatever they want with it? How do you create a discipline around it that you create your own firm approach to using AI? It seems like that's a huge challenge going forward.
Yeah. So first, as I mentioned, we are in the early days, right? So there are a lot of things that we need to figure out as an industry, as technology vendors, etc. I think we need to understand the benefits of using AI. So I think companies need to start learning about what AI can do, what AI is good for, not so good for. I think it's important to understand, to go with an open mind to understand the potential. What we started to see more recently, because engineering firms collect a lot of data, and I think we started to see more and more of these firms hiring data scientists. So I think data scientists are becoming, key new types of employees for the firm of the future. More and more, everybody I'm sure on this call create a ton of data. Data is the new gold or the new oil or the new thing. And I think we need to, all of us need to better understand the data we create. So I think there's a world where we'll have more data scientists part of our firms. Construction companies do a ton of it because they want to better understand how they perform, to do scheduling, to do, predict risk on the job site, etc. And then engineering companies, started to do a lot more. So I think it's critical to start hiring data scientists.
Awesome. Great safety applications is just one example.
Yeah.
Daphne, there's some great questions in the chat box. Turn it over to you to ask a couple of them.
Yeah, and just kind of keying off of what Nicholas just talked about related to data scientists, one of the things we were talking about is this need for new types of employees, right? And the firm of the future needing potentially a VP of AI. How far away is that, Nicola?
So I think, back to the digital twin question, I think our industry has been used to, design and build physical assets. So we have great, engineers, we use digital tools, but we still design a physical asset. I think that more and more will need to become also digital designers of digital assets, right? So not only designing physical, we'll need to design digital. So I think that in this spirit, there will be new roles, there will be new responsibilities, for people to do it. I don't know if it's going to be a VP of AI or a VP, of data science or digital delivery or but there will be, some sort of, new titles, I think. And maybe, these type of folks will be the ones that will maintain, this digital asset with the owners as opposed to the physical asset.
So speaking of the owners, this next question, you talked about all the data, big data, and collecting data from a lot of places and using it in a lot of different ways that you shared with us today. Some of our firms work with clients who have very sensitive data, right? Federal government, even, data that has national security implications. What is the future of that? How do you see this playing out over the next 3 to 5 years as more things become digitized? Have you had any discussions with those types of clients, and how do we overcome that challenge?
Yeah. I mean, definitely there are more requirements like FedRAMP, for instance, that everybody needs to support. Yeah, I mean, it's at the center of almost every conversation. Maybe a little bit less in the US, because the one thing that some of you might or might not know is in the case of Autodesk, but for other technology companies, it's similar, but we are based on Amazon. And then all the data for foreign projects, actually reside in the US most of the time. So it's even more amplified outside, like right now, the Parliament of England, for instance, or, sensitive projects. I was just in Japan and Singapore in the last few weeks, and then, it's all over. So the topic of secure access, is at the center of everything, we do at Autodesk, and I know every company is doing the same. So, so I think it's top of mind for everybody to provide this secure access. And you will see, lots of investment from the planet, all the software vendors, in this area.
Are you seeing any governments that are gotten to a point where they're comfortable in releasing that data yet?
What do you mean by releasing the?
Well, just the ability to share the data, right? Put it in the clouds, those types of things.
Yeah, absolutely. Yes. Yes, in Ireland, they are quite advanced, for, big transportation projects, security projects, airports, etc., for instance. So, yeah, lots of governments started to share, but I think there's still a lot more work to do. And in the US, when FedRAMP requirements are implemented in technology, FedRAMP is also something that's required for a lot of the public projects. So that's going to help for the US, for sure.
I have one question here, Nikolai, that comes from the audience. I'm going to try to translate it, but I think, Daphne, what you're going to find is data scientists with government clearances are going to be in really strong demand.
Yes.
Yeah, that's a double major that I wish I was younger to go get. Nikolai, one of the panel listeners here asked a great question, and it's about liability. So obviously you're creating a digital twin. There will ultimately be some errors or misjudgments in the data that you picked. How do you go about developing a QA/QC program over AI?
Yeah, I mean, that's where AI actually is actually strong, right? Because AI can analyze a lot of data and understand some of the code compliance or some of the errors. AI can understand if something is structurally stable or not. Are we missing support or whatnot? So I think AI will be part of it. AI will be part of validating it. But still, we are still in the early days of creation of digital twin. I think that we'll need to go through a lot of processes and implement a lot of processes for QA/QC. One thing I didn't mention, maybe I should have, in the generative AI. So, remember in the digital twin section, I said that at the end of the construction, typically construction companies, GCs, will try to create a digital twin, towards the end, and then it's not perfect, and then it's not used, right? But one of the things that AI will be good at, just like the AI will be able to, generate structures that do not clash, for instance, it will also generate in the background the digital twin. So the digital twin, instead of being generated or built towards the end of construction, it's going to be designed, very early, in planning phases and kept being updated. So that's going to ensure also, QA, QC, because it's going to be, quote unquote, right from the beginning, right? Yeah.
So, Nikolai, I got a question I think is a good one to close out with. And the question is, with the development of digital twins, who ultimately wins? Who benefits from this? The owners, the contractors, the AE firms? What's your sense of that?
So first, the owner will win, for sure, because the owner will become more digital. The owners are less digital than us in engineering firms, right? So they will be able to do two things. So they will be able to optimize their facilities in the short term, better performance. They'll understand, carbon, energy, occupancy. So lots of things that they have no idea today, they will understand and optimize. So I think that's one. And then two, they will be able to reuse that knowledge for the next project. So they will be winners. I think the others that will win is whoever can provide these services to the owners, because the owners won't be able to manage, these digital twins. So right now, I think there will be a race between the A's, the E's, and the C's in terms of who's going to be the best position to provide these services. So that these will be the winners of this digital world, right? So it's a digital transformation. Somebody is going to win providing digital services.
Sounds like we're off to the races.
I can definitely see engineering firms being a more welcoming environment for data scientists to hang their hat in than contractors. So hopefully our industry takes the lead in this developing technology. Nikolai, thank you so much. I'm going to turn it back to Daphne, but your insights and thank you to Autodesk for allowing you to share this information with the whole industry. It's been very insightful, and I feel like I, for one, among others, have a better sense of AI and digital twins. So thank you for that. Daphne?
Completely agree, Kevin. Thank you, Kevin, for getting us through this session. Nikolai, as always, lots of great information. You make my brain hurt, but I appreciate that. Thank you all for joining us. I hope you enjoyed this session. We have a great lineup this fall of sessions each month coming up. So I hope you'll take a look at that on our website and get registered for many more insightful opportunities to engage with us in the Future of Engineering Roundtables. Thank you again to our donors who make these possible, and I hope you all have a safe and good afternoon. Thank you. Take care.
Thank you. Bye.